Before our class starts, we just want to give you a motivational quote that is somehow connected with our topic. In life, drawing conclusions based on test results is like connecting the dots of our experiences. Each test is an opportunity to learn, grow, and make informed decisions. Remember, the power to shape your path lies in the conclusions you draw from the tests you face. Now, let the lesson begin.
Drawing conclusion about population proportions based on the test statistic and the rejection region. Our objectives in this lesson are the following: compute for the test statistic of population proportion, differentiate critical value approach from p-value approach of hypothesis testing, and draw a conclusion on population proportions based on the test statistic and the rejection region.
These are the approaches in hypothesis testing. Critical value approach. The critical value approach is the computed value is compared to the critical value. If the computed value falls on the rejection region, the null hypothesis is rejected. While p-value approach, the p-value is compared to the significant level alpha. If p-value is less than or equal to the alpha, we reject the null hypothesis. If p-value is greater than alpha, we fail to reject the null hypothesis. Hey everyone, here is the diagram. First, we state the null and alternative hypothesis, and then we decide on the significant level if in case it is not given in the problem. Third one, we decide on the test statistic and compute for its value. From here, you can choose from two options. It's either critical value approach or p-value approach. From critical value approach, you have to determine the critical value and compare that with the computed value found in step 3. If the computed value falls into the rejection region, we reject the null hypothesis. If you choose the p-value approach, the first thing to do is to determine the p-value and then you compare the p-value to the significant level from step 2. If the p-value is less than or equal on the significant level, we reject the null hypothesis. Whatever you choose on these two approaches, it will lead to same decision and conclusion.
P-value is always written with italicized P and with space on both sides of the equal or inequality symbol. P-value is any value between 0 and 1. Do not write 0 before the actual p-value. Write p less than 0.05 instead of p less than 0.05. Use actual p-values. Example, p equal 0.025. If limited tables of critical value are used, use p less than 0.10, p less than 0.05, or p less than 0.01. If p greater than 0.01, use 2 or 3 decimal places. If p less than 0.01, it should be expressed in 3 digits. Technically, p-values cannot equal 0. Use p less than 0.001 instead of p equal 0.000. If p-value less than 0.05, typically less than or equal to 0.05 is statistically significant. It indicates strong evidence against the null hypothesis. A p-value higher than 0.05 or greater than 0.05 is not statistically significant. It indicates strong evidence for the null hypothesis.
Let's know more about p-value. P-value is the measure of the strength of evidence against the null hypothesis. So the smaller the p-value, the stronger the evidence that the null hypothesis should be rejected. As I mentioned earlier, if p-value is less than or equal to alpha, you reject the null hypothesis. If it is greater than alpha, you fail to reject the null hypothesis. If alpha is not given, use 0.05 as the threshold. Now, in a more understandable way, let us define p-value as the probability of obtaining a sample that is more extreme than the obtained test statistic, assuming the null hypothesis is true. To give you an idea, consider this right-tail test. Let us say this line here is the computed value 2.53. Where is the p-value? The p-value is the more extreme values. So if this is the critical value, the more extreme is the value to the right of it. So this shaded area is the p-value. If it is a left-tail test like this one, and this is the computed value, the more extreme values are to the left of it. So this is the p-value that we are looking for. There are several ways on finding the p-value. One is if you have a TI calculator like TI-84, you can use the normal CDF function there. Another way is to look for computer programs that give p-value. Or you may use the normal table, which I am going to show you now. So let's have an example. Here we are given the null and alternative hypothesis, as well as the computed z-value and the level of significance. So the first thing to do is to plot the computed value. 1.98 is somewhere here. Let us label that. Again, p-value is the more extreme values. If it is a right-tailed test like this one, it is the values to the right of the computed value. So here is the p-value that we are going to look for.
To do that, let us break out our z-table. Let us look for 1.98. Here is 1.9 and then 0.08. So the area is 0.4761. Is from the mean up to 1.98. But this is not what we are looking for. We are looking for area. You all know that half of a normal curve is 0.5. So to solve for this area, here we just have to subtract 0.4761 from 0.5, and that will give us 0.0239. This is the p-value that we are looking for. Now let us decide, since 0.0239 is less than 0.05, the alpha level, the decision is reject the null hypothesis.
Hello! Now let's find the p-value of example number 2. Here are the solutions step by step. For step 1, state the hypothesis. The first step in hypothesis testing is to set the hypothesis. Here the null hypothesis is P equals 0.35 and the alternative hypothesis is P less than 0.35. Step 2. Use the provided test statistic. In this case, the z-score computed z-value, z-com, is given as negative 1.07. For step 3, find the p-value. The p-value is the probability that a z-score is extreme as or more extreme than the observed z-score. We calculated this using statistical software and obtained a p-value of approximately 0.1423. Step 4. Make a decision. Compare the p-value with the significance level alpha 0.10. If the p-value is less than alpha, we reject the null hypothesis. In this case, the p-value is larger than the significance level, so we do not reject the null hypothesis. Now, let's calculate the p-value of example number 3. The calculated p-value is approximately 0.0178. Let's proceed with the explanation. Here are the solutions step by step. First, step 1. State the hypothesis. The first step in hypothesis testing is to set the hypothesis. Here, the null hypothesis is p equals 0.82, and the alternative hypothesis is p and not equal 0.82. First, step 2. Use the provided test statistic. In this case, the z-score computed z-value or z-com is given as 2.37. Step 3. Find the p-value. The p-value is the probability that a z-score is as extreme as or more extreme than the observed z-score. We calculated this using statistical software and obtained a p-value of approximately 0.0178. First, step 4. Make a decision. Compare the p-value with the significance level alpha 0.05. If the p-value is less than a, we reject the null hypothesis.
Stating conclusion. Conclusion is the interpretation of your decision that includes 3 factors. Number 1, whether sufficient or insufficient evidence. Number 2, the level of significance. And number 3, whether to reject or support the claim. So when the decision is reject the null hypothesis, you state, there is sufficient evidence. There is sufficient because you reject. There is sufficient evidence at, let's say, 0.05 or the level of significance to reject the claim that, let us say, that the claim is men prefer engineering courses than women. Or you may say, there is sufficient evidence of 0.05 or level of significance to support the claim that men prefer engineering courses than women. When the decision is failed to reject the null hypothesis, the word that are we going to use is there is insufficient evidence at, let's say, 0.01, the level of significance to reject the claim that men prefer engineering courses than women. Or you may also say there is insufficient evidence at 0.01 or level of significance to support the claim that men prefer engineering courses than women.
So here we are tasked to solve this using the critical value approach. Study and analyze the given data and draw your conclusion. We are given here the null and alternative hypothesis and also the alpha level and the computed value. Since we are asked to solve this using critical value approach, we are going to need our 2 critical values. Alternative hypothesis state that less than 40%, less than, so this is one tailed test, particularly left tail, at 0.10 level of significance. So our critical value is negative 1.87. Let us plot that. Negative 1.28, so somewhere here. Let us label it, and the rejection region is to the left. Now let us locate negative 1.87. It is somewhere to the left of the critical value and falls within the rejection region, so our decision is reject the null hypothesis. Now how do we interpret our conclusion? Since we reject the null hypothesis, means we have sufficient evidence. There is sufficient evidence at 0.10 level of significance to support the claim that less than 40% of grade 12 students hates research. Now let's do this using the p-value approach. This time, what we are going to plot is not the critical value, but the computed value. Negative 1.87 lies somewhere here. Let us label it, and the p-value again are the more extreme value. If it is a left-tailed test, it is on the left of the computed value. Let's bring out our z-table. Let's look for positive 1.87 instead, so 1.8 and 0.07. So the area is 0.469. This area again is from the mean up to negative 1.87, and we don't need this area. What we need to compute is the shaded region here. So to do that, we know that the half of a normal curve is 0.5. Let us subtract 0.469p from 0.5, and this will give us 0.0307. This is the p-value that we are looking for. Now let us decide. Since 0.0307 is less than 0.10, the alpha level means the decision is to reject the null hypothesis. And for a conclusion, since we reject the null hypothesis, it means that we have sufficient evidence at 0.10 level of significance to support the claim that less than 40% of grade 12 students hates research. Notice that we end up at the same conclusion even if we use p-value approach. This only proves that whether you choose critical value approach or p-value approach, you will arrive at the same conclusion.
Now, let us proceed to the extra challenge. The meaning of the symbols you may encounter are: first, for P is hypothesis proportion, for P hat, sample proportion, N for sample size, X, number of elements or observed values, and the formula for sample proportion is equal to sample size over the observed values. Now let us do extra challenge using critical value approach. We have here the null and alternative hypothesis, the level of significance, the sample size, and the number of success. So we still need to compute for z value. First, let us determine our p. Our hypothesis proportion is 56%, so p is equal to 0.56. Then let us solve for our q, and that will be 1 minus 0.56, and that is 0.44. Let us also solve for our sample proportion, and that is sample size over the observed values. So that will be 117 over 300, and this will give us 0.59. Now to determine if the sample is sufficiently large, let us solve for the NP. Our N is 300, P is 0.56. This will give us a product of 168, and this is greater than 5. Now let us solve for our NQ. Again, our N is 300, our Q is 0.44, and this is equal to 132, also greater than 5. Let us add these two, and this will give us 300, our sample size. Now let us solve for the z value. Let us substitute our given here. Our sample proportion is 0.59. Our P is 0.56. Again, our P is 0.56. Our Q is 0.44. And our N is 300. Computing this, it will give us 1.05. Let us continue. Let us recall our Z critical values. Since this is more than, this is a right tail test, and 0.01. So our critical value is 2.33. Let us plot that. 2.33 somewhere here. Let us label it. And the rejection region is on the tail of the curve. Now let us locate 1.05, and that is somewhere here, and it falls within the non-rejection region. Therefore, our decision is fail to reject the null hypothesis. For the conclusion, we fail to reject it means we have insufficient evidence at 0.01 level of significance to support the claim
that more than 56% of OFWs are female. It's time to check your understanding. Pause this video for more time. Let us answer this. This is the same problem that we did in Extra Challenge, only this time we're going to use the p-value approach, and let's find out later if we will be having the same conclusion. So let us plot our computed c-value 1.05. So somewhere here, let us label that. The more extreme values are on the right of the computed value. Let's have our z-table. 1.05. Here is 1.0 and then 0.05. So the area is 0.3531. This area again is from the mean up to 1.05. Solve for this area. Half of the curve is 0.5. So let us subtract 0.3531 from 0.5, and this will give us 0.1469. This is our p-value. Now let us decide. Since 1.69 is greater than 0.01, our significance level, the decision is fail to reject the null hypothesis. Since we fail to reject it, means we have insufficient evidence at 0.01 level of significance to support the claim that more than 56% of OFWs are females. For the summary, here are the things that we discuss in this lesson. Take time to understand this. Now I believe you are ready for our 10-item recorded quiz.